Here we have second problem. The block of mass 1.1 kilogram stays at rest on horizontal surface with coefficient of kinetic friction. When arrow of mass strikes the block with a speed 86 meters per second, it gets stuck in the block. Find the distance to which the block with arrow will slide after strike till they come to the rest. Okay, so here we have a block. It's at rest, so V initial 1 becomes 0. Then we have arrow, which has a mass, let's say m2, and it has initial velocity V initial 2. Now, it strikes, after that it moves or slides a certain distance and it stops, okay? So kinetic friction is also given, all the data are given. So let's start solving it. So we have to find till what distance it will move, okay, until it stops. So we know that when it hits and it moves certain distance, the final velocity of the box becomes 0, and it stops, and we have to find that distance, okay? Now, we have to divide this thing into two parts. One is initial of this one, which is coming to momentum, and it stacks, hits, and then just before moving, the mass 1 and mass 2 will have a certain velocity, okay, which I call final velocity, but this will be equal to the initial velocity, okay, when we consider basically this part, okay. So we have two parts. This first part, let's call this is second part, okay. So let's start first with consideration of the momentum. Momentum initial is equal to momentum final. Mass 1 V initial 1 plus mass 2 V initial 2, and then it's equal to the final momentum when mass 1 plus mass 2, because they stuck together, and multiply to the final velocity. Since box is at rest, so we make it equal to 0. From here we have to find what is the V final. So V final will be equal m2 V initial 2 divided by the total mass, okay. So you solve it together and you get 13.23 meter per second, okay. So this is 13.23 meter per second is the highest velocity when it just starts sliding, okay. When it just starts sliding, let me 13.23 meter per second, okay. Now it just starting to slide, which will have highest velocity, and then as it moves further, the velocity becomes less and less. Finally it will stop, okay. Now, in order to consider the second part, which is this part, what we have to do is that we know that work done by friction will be equal to the change in kinetic energy, okay. So basically all the kinetic energy will be converted to the work done by friction. So our work done by friction is equal to the friction force multiplied to a distance is equal to the change in kinetic energy. The friction force itself is equal to the mu k, and then we know that this arrow and the mass, they stuck together, so we have to add this m1 m2 multiplied to the g multiplied to a distance, okay. So this is already, you know that the normal force we have here, so the friction force itself is equal mu normal force, correct? So normal mu kinetic friction, normal force will becomes mg, okay. So anyway, so you have here work done by friction, which is mu k, total mass, gd. What about so by plugging all the numbers which are given, we could calculate that it's equal to the 1.911 times d, okay. D we can find it. So what about then changing kinetic energy? Changing kinetic energy will be equal to the kinetic energy final minus kinetic energy initial. In the final kinetic energy, we know that it will be equal to 0 because mv square over 2, and our initial kinetic energy will be equal to the total mass m1 plus m2 multiplied v initial squared over 2. So this v initial squared, actually this one or this one, okay, which is just started with the highest velocity. So by plugging the numbers, we can find that change in kinetic energy will be equal to the 113.77 joules. Okay, so since this negative sign means that the work done by friction will be also a negative sign. So by taking it this way, so we have calculated work done by friction, this number multiplied by distance, and then changing kinetic energy. By dividing, so we will get that object will move 59.53 meters before it stops.